So today we're going to talk about effective data warehouse storage patterns. Let me bring up a web browser and talk about some things. I've had the privilege to be an MVP on and off. I worked for Microsoft for a couple of years, for 8 years, hopefully number 9 coming up. The most important thing out of this whole presentation is this link right here. So GitHub, John Miner 3. Community work. And on the community work, I have a bunch of presentations. The one we're talking about today is effective data warehouse storage patterns. Okay, we're going to go over a bunch of different techniques and how to make things go faster. If you're curious, I'm an avid reader, I'm a writer and reader of MS SQL tips. I've been writing for them since 2015, and I have about 125 tips, various technologies. So Spark, which I'm doing a lot of Databricks, Azure, a lot of Azure, Data Factory, SQL Server, obviously, some DevOps in here, even some Google, Power BI, partitioning. There is a couple partitioning articles in here, database sharding, partitioned views, okay, as well as table partitioning, and those will be very specific to today's talk, so please take a look at them. I'm going to close this one. If you're curious, you can reach out to me. I'm a data architect at Insight. This is my LinkedIn page, okay? With that said, and we're talking to Kevin, and before is that, most things are done in the cloud. So I'm going to be using a virtual machine in Azure called VM4. And this is the convention I'm using, virtual machine for SQL, and it's 2019, of course. Okay. So let's minimize and get into the slide deck. Screen, 5% of view, perfect. Okay. So again, MS SQL Tips is where I write. I also have a blog that I started before I became an MVP. It has about 300 just specific SQL tips, and so you can look at Crafty DBA. And this is my little avatar here. Some things, I've been around the block. Wow, started in 1991. So what is that? 33 years in technology. So time flies for sure. Thank you again for Data Weekender for picking me. I've been an avid component and a supporter of many groups, including PASS, the Boston Code Camp, a lot of the code camps like in New England. One of the reasons why I keep on teaching and learning is because technology changes so fast. And that's one of the things that Kevin and I were talking before you joined, is that there's a lot of products that used to be around that are no longer there. So it's good to stay current. One of the things that's good about SQL, and there was recent announcement, from Bob Ward. He just celebrated 30 years at Microsoft. SQL Server's been around 30 years. So what we're talking about today is probably going to be around before I, might even be dead, but and still be people working on SQL Server, right? So another 30 years. So this is something you have to keep on doing, certifications, Microsoft, and the company I work for now for the last 6 years is Blue Metal. They're no longer called Blue Metal because we were purchased by Insight, okay? And this is the old deck that was started back in 2010. And like I said, first SQL Saturday I went to was 30 in Boston. So what are we going to talk about today, right? We're going to talk about some goals, right? What do we want to get out of this talk? For developers, we want to know what's the difference between 4 different storage patterns we're going to talk about. And, column store came later, 2014, 2016, if I remember right. And we're not going to talk about those, but column store is a great technique for if you're doing OLAP, online analytical processing. Then it is a great way to compress data and make it go fast, okay? But today we're going to talk about other techniques, okay? And if you're a developer, you should know them and how to design them. And if you're an administrator, okay, you want to preach these patterns, because I had a client recently, and it was actually a financial client that had a 1.2 terabyte database, and they wanted to use general purpose. They didn't want to spend more money on it. And the queries were taking 5 minutes to run. And again, it was a 1.2 terabyte database. I happened to use column store on that. but you could have used some of these other techniques too. We reduced it down to 12 gigabytes, right? And the processing time, like I said, in those reports were taking 5 minutes. We got it down to 5 seconds. Okay, so the goal is to reduce the size and or organization maintenance, cost of the database and provide performance. Okay. So typical business problem. One thing you might see is that a lot of people create a database, right? And they start collecting data mart, right? And suddenly people start using it for decision making, right? Key performance indicators. And because it caught on really well and the growth of the data happens, guess what? The system starts getting slow, just like the example I talked about using stocks, right? Or investments. So we want to reduce the size of the data mart and speed up data retrieval, okay? So I'm going to go over what we're going to talk about today. So these are the topics, okay? So what's the difference between horizontal and vertical partitioning, okay? What is database sharding, right? And to do this on premise, I mean, you can do it in the cloud. In the cloud, the syntax is different. And again, go to MS SQL tips, and I have examples of that. You don't have to worry about file and file groups in the cloud. However, on premise, you do, okay? So you want to worry about file and file groups. We have to talk about that. We're going to talk about partition review. So each one of these is a different way to segregate the data so that maintenance is easier. Say if you have 5 years of data, you don't want to back up a database that has 5 years of data that doesn't change, right? You only want to back up this month's data that's really changing, right? And unless you're a company that might be doing fraudulent practices, like in the U.S. there's Enron, you're not going to go rewrite history, right? So that old data can be, compressed, segregated, and backed up once, and then guess what? As long as it's available, people are happy. So we're going to talk about database sharding, partition views. We're going to talk about different compressions, row and page. And the last one is how to design a table partition, okay? And this is the secret sauce from Microsoft, okay? And we'll just compare timings on it, okay? The subjective timings, they were done a long time ago, so do them again. One of the things I want to talk about is clustered column store indexing. I'm just going to give you like a little intro into it. It's really only effective if you get 1 million rows. And if you're using a product like SQL Data Warehouse, which is now Synapse Dedicated Pools, and I don't know what they call it in Fabric, but it's only valid for like 60 million rows, okay? So that's because the sharding index, they have 60 files. Before, and most people, hopefully you're past SQL Server 2016 SP1, but before some of these things like, table partitioning, you had to have the enterprise version. And what they did is basically to keep up with everyone else, all the free open source databases, they gave it away in 2016 SP2. So I always liked Dilbert. I mean, I grew up in the 90s. Scott Adams was poking fun at everyone, but all the demonstrations are code-based, okay? So I'm going to show you how to do it. We're going to take a small example and do it. I'm not offended if this is not your cup of tea. Go find another track. I mean, there's plenty of good speakers today, but I'm hoping that you're going to stay with me. This one's a funny one because I wanted to tell you this was done in, I'm looking at it, 1995, right? And Scott Adams almost had it right? So he says, I think the database manager comes and says, I think we should build a SQL database. And Dilbert's like, uh-huh. And does he understand what he said? Is it something that we saw in the trade magazines, right? Because, most managers are not in touch with technology. And Dilbert says a funny question, goes, hey, what color do you want in a database? And, the manager says, I think mauve has the most RAM, right? And if he put azure, which is a blue color, right, he would have been perfect, right? So we have to have a demo database. So I'm going to talk about my Big John's barbecue. I like doing barbecue. And so I just created a very small fictitious database that has 1 million records, okay? Something that we can do stuff with, okay? And the premise is that each customer gets a monthly delivery of some type of pig parts, right? So maybe some bacon, some pork shoulder, pork butt, so on, right? So we get packages and dates, which are dimensions, okay, and we have 1 million customers, which is our fact table. So it's a very tiny example, but it's good enough that we can show you the techniques. Okay. Um, if you ever get in a pinch, okay, and again, I am not vendor specific when it comes to using tools. Oracle Developer has a tool for drawing diagrams, and so this is, and it's free, by the way. So this is using Oracle Developer, so we can see that we have the customers and we have like some demographic information. We have a couple dates, right? We have a start date and end date, and those bring to the date dimension. And we also have a relationship from the fact.customers to the pig packages. To make life easy, I have a date string of when, it was sent out for the packages. And we also have a petition key, right? So customer quarter key, okay? So we're going to try to partition by quarter, okay? And we have 2 years worth of data, okay? If you're curious, like Kevin and I were talking about, pigs, here's the parts, right? You get the hag. I like pork buck for a pulled pork, but in a pinch, if I get a Boston shoulder, I won't complain. And, this is your bacon right here, okay? So let's talk about some things, right? One of the things that was introduced, and again, I'm getting old, but I think it was 2012, is schemas, right? And SQL Server introduced schemas to basically keep up with, um, you know, Oracle, right? Oracle already had them. And schema is a great way to, segregate and secure your data. And again, schemas, I got it wrong. Sequences are the new thing. Schemas have been around for a while. And so the bulk insert is a quick and dirty way to import data, okay? And sequences are new, okay? In 2012, we'll talk about them. Another thing is you can do calculated columns, okay? And so I'll show you that. And of course, we want to use primary and foreign keys to enforce relationships. So I'm going to get into the code pretty soon. There's a few things I want to talk about is partitioning, right? And we're very first example is going to use horizontal positioning versus vertical, okay? So vertical is when you have too many columns in the table. And again, it's just a bad entity relationship diagram design, okay? And with that, sometimes you split it into two different tables. So I got my primary data in one and my secondary data in two. I suggest not doing that, okay? If you have to, go ahead, but it's just bad modeling practice, okay? What we're going to focus on today is horizontal partitioning, okay? So I got some records from quarter of 2011, Q1, and I got some records from quarter 2011 Q2. And we want to put them in different databases. That's the very first thing, is database sharding, okay? So why do we want to partition data, right? It's usually done for manageability, and we talked about it already, backing up, indexing, so on. We do it once, we can set a read only, you don't have to worry about it. Second thing is performance, right? Because now, think about it, when you do a search, right, a select, and then it's a where clause, right, the engine somewhere has to do some type of tree retrieval, right? And it's n log n operation, right? Bigger n, the longer it takes, right? Smaller n, shorter it takes, right? So if we're partitioning into different databases and your application can say, hey, use this quarter and let me look at my data, then guess what? Things go faster, okay? Availability too, right? One of the things is that once it's backed up and it's read-only, it's always available, right? You're not making changes. So let's talk about the benefits of horizontal partitioning. This is the very first example we're going to go over. So objects such as file groups can be set to read-only. We talked about that. We can also separate the databases on separate databases, file groups, and guess what? On those other ones that you've backed up, you've compressed, you reorganized, indexed, there's not going to be any page splits anymore, right? You're not sticking all the data in one thing and for some reason you caused a split. It's in a database that is pretty much static, right? Backups, right, can be done quickly. So you only have to back up the most recent database, right? And we can reduce contention. It depends on which sharding you're using when loading. So if we were, say, adding a new week and we sharded by week, guess what? That week, that's extreme case of database by week, right? We wouldn't have to show the new week. People could be using an old one. We load it, and then suddenly we give it to the application, okay? So let's get into the very first example. The thing with database sharding is that there's really no easy way to do it. It has to be done dynamically, okay? So we're gonna have to dynamically create a database based on some partition key, right? And so it's the values of a column. What's an easy way to do this? To use a SQL instance, right? So when you do a SQL instance, okay, and what we can do is we can put everything in model. And when we do create database, guess what? It suddenly inherits the table's index and all the objects, right? That's one way to do it. Optionally, we can do it by code, and I'm going to show you the code one because it's a little more complex, and I like complex. So at this point, I'm going to pause. Is there any questions, Kevin?
No questions at all at the moment, John, to be honest.
Awesome, awesome. Everyone's staying on board then. Perfect. So what we're going to do is we're going to go back to the portal and say, yeah, this is a VM, right? And how do you get to a VM? If you haven't used Azure, right, you can go connect. And it's kind of new now, they're forcing everyone, you can download native RDP, and you're going to get an RDP session right here. And again, I'm trying to be very specific so everyone can do this in their own, follow the video later. And I have it here. I'm not going to show you this, but this is my key to there. And if we double click this, it's going to tell me, hey, do you want to connect here? And I already saved the credentials, you put it in, and boom, we suddenly get a session like above here, okay? Oops, and I hope I didn't get rid of it. Windows 11, I just upgraded, and it's a whole new world. So inside the VM, and you can see nothing spectacular here. I got VS Code and I have SSMS. So we got SSMS, and I'm gonna hit refresh. Okay, I was just testing my example, so I'm going to delete this. When we delete this, we want to delete any backups, but we also want to close the connection just in case we're on it. Now it's gone. And this is our original database that we want to shard, okay? So we got our dim date, our dim packages, and our fact customers. If we select, we can see some data here. We can see that we have the date, and that date has been translated into a key because 7/29 of 2011, when we shipped the package 3 to this customer, okay, basically falls in the third quarter of 2011, okay? And if we're curious about account, we can go here and do account star, and we can see there should be 99999. So it's one less than a million, okay? So I'm going to open up the file, and the very first file we're going to go into is database sharding, right? And what we're going to do is cursors. Yeah, most people curse cursors. They don't like them, try it slow. But the
John,
good for, yeah.
I was just going to say, we do have a quick question from somebody. I would have waited, but whilst you're
Sure.
on this particular topic, I think I better ask now because otherwise we'll have to backtrack. The question is, are these patterns applicable for Synapse as well?
Okay, so Synapse has two types of things. It has Spark, okay, and it has a dedicated pool. And the dedicated pool is using basically what we used to use, Parallel Data Warehouse, PDW, which went through many different names, Azure SQL Data Warehouse, and then it became SQL Server. I meant Synapse dedicated pools. That's a totally different thing. It's a data warehousing technique. At the underneath, there is ready sharding going on. This is very specific to SQL Server. So any flavor of SQL Server, Express, Standard, Developer, Enterprise, where it's housed. So Azure SQL Database supports it. Managed Instance supports it. If you're using AWS, it supports it. And if you're using GCP, it supports these techniques. It depends on and again, I want to backtrack a little. It depends on the actual service provider. So, sharding, definitely support it. Just create a new database, create some schema, and guess what? Put the data in. If you're using a service like Google, and again, I don't want to get too off tangent. I want to get into the demo and show you the techniques. then you might not have access to control the file layout, but you do have access to create a new database and create a new scheme, okay? So I hope that answers your question. If not, you got my email, john.miner@insight. Please send me an email. Okay, so what we want to do is we can see right here that we only have one database, right? And what we want to do is we want to make 8 databases. We have 2 years worth of data and we want to do it per each quarter. So what we're going to do is we're going to use basically a loop, a cursor, right? While the year is less than 2013, the quarter is less, set it to 1. If it's less than 5, then guess what? We have to do exactly like we're doing it by hand, right? If the database exists, then drop the database, right? And then again, I got debugging in here, you can turn it on. And then the next thing is, okay, create a database. And now we have to give it a file location, right? And a log file, right? We execute that. Then what we want to do is we always want to have the owner of a database be SA, right? Because otherwise you can have a broken chain. Like, Kevin owns it, he leaves the company. Oh my God, maybe I don't have access anymore. So put it to SA, okay? Then what we want to do is we want to create schemas, and I'm using schemas in here, right? So there's a fact schema and there's a dim schema. So we're creating those 2 schemas, right? Then I'm going to create the pig package, which is your dim table. The date is another dim table, right? And then what I'm going to do is we're doing hashing, right? So we want a function that says hash. It takes a date string, and then what it does is it returns an integer because we're going to hash on the integer. And then we create a fact table. So we're going to use the database. We're going to create the facts. And again, I'm going fast. You can take a look at the details. And what we're going to do is we're going to alter table and we're going to add the primary key. We're going to add some defaults, right? And then what we're going to do is we're going to do our relationships, right? So we're going to do a constraint foreign key to the pig packages, and there's 2 dates, right? Start date and end date, and execute. And then last but not least, now we've created schema. How do we load it, right? Well, we're lucky. We don't have to do ETL. If it was a different server, say we're in the cloud, regardless of whatever, say Azure, and I had this on premise database, I need to move it. I need some ETL to do it, right? So maybe ADF, whatever you want. We're lucky. We're still in the same server, right? So I can just do insert into. So I'm going to do insert into for the pig packages. Same thing with the dimension table. And same thing with the customer table, okay? And I'm just going to let this rip, okay? And what we're going to do is I'm going to show you the first one, and I'm going to get back to the slide and let all 8 run. So we can see the very first one starting to go. And now we can see there's some tables here, right? And now I did beef up the cores on this, not too much, but I did put some horsepower behind here. So let's see if it's done doing it. Nope, there's no rows yet. Okay, and let's do a count. There should be around 128,000 if I do my math right, and multiply by 8, 125,000, well, 23. And you multiply by 8, that's your million rows, okay? So I'm going to go back to the slides. We're going to let that run. It's going to build all the databases, okay? So what did we do? I mean, the main thing is, why did we do this, and what's the pros and cons, right? So I'm going to hide the presenter view and go here. Okay, so what did we do? We had a database sharding diagram, right? So we basically created a database, okay, for each of the quarters. We replicated the dim dimensions, dates, and packages all over the place. And we created a customer table, and we pushed the data for that quarter and year into the customer table. What's the pros and cons? This is before the enterprise version versus the standard version, so it no longer matters, but for historical reasons here. So basically the table and index size was reduced by end, right? So it's a lot smaller, okay? Second thing is, usually when you delete from a table, and it's a huge table, not a million, but say a billion rows, right? It has to go through all the pages and mark them, right? That's a very costly operation, right? This is a metadata operation now. We just drop database, it's done, it's gone. There is a limitation though. There's 32,000 unique databases. So if you need to shard by 32,000, this is not the technique to pick, okay? But cons, right? When you write an application, the application developers say we're selling pigs, they have to pick the quarter to look at the data. They can't really do it, right? Second thing is, how do we aggregate data? We have all these shards, right? We could use cross-database queries if it's locally, or even in the cloud, maybe Azure SQL Database Managed Instance, using a technique. But we still have to say, okay, I want to see all the data for all customers and all sales. 2 years, guess what? We're going to have to union 8 tables. 4 years, we have 16 tables. So there's some maintenance on aggregations, right? And also we have to write code to add, load, and delete database, okay? But it is a good technique. I've used it in the past. So let's talk about file and file groups, okay? So every database has at least one primary file group, an MDF, and one log file. But we can do secondary files, right? Okay, and that's good when you want to get more pathways to your storage, okay? So especially on premise in the days in which I had to worry about the CN, I wanted to say, hey, I want 5 different pathways to the CN. Hopefully it goes faster IAPS. So I'd create 5 different files and make sure they map to the different volumes on the CN, and hopefully it would go faster. There's always a primary file group, okay? But we can also add dictionary file groups. We're going to talk about that. And there can be a one-to-many relationship between file groups and files. So we can have one file group, but we can make 5 files to it. So that means when we create a table on file group A, it's going to suddenly push the data to 5 different files, which hopefully go to 5 different places on the CN. So this basically spreads the I/O over on multiple disks, and hopefully things go faster. Okay. So we're going to talk about the partition view design. Okay. So we need to dynamically create files, file groups, and tables based on the values of the hash key. So that hasn't really changed. There is one secret sauce to this technique. You have to use a check constraint on the hash column, okay? The primary key must be included in the hash column, can be the last item in the list to improve selectivity, okay? And when we do a union all, which is a view now, again, we're taking views on tables, we have to do schema binding. Interesting fact is it could be local distributed. I'm gonna push you and say, don't do distributed, link servers are slow, right? But local's great. And insert, update, and delete actions use the same rules as view. So if you make your view and it's on 2 different tables, right, you cannot go ahead and, update both sides because it can't do that, right? You only can update one table at a time. So look at the documentations on views and the limitations, right? So partition view example, okay? I'm going to get to the diagram, then we'll get into the actual how you do it. So before we partition by database, now we're going to partition by table. So we're going to put the data for 2011-01 to one table, next data for 2011-02 in the next table, and so on. Good thing is we don't have to replicate the data for dim date and dim packages, but we're going to use this union view to make it look the same, okay? I'm going to leave the pros and cons for the end, and we're going to go to the example. And Kevin, another perfect time to ask questions.
Indeed, and there are no questions in the chat at this moment in time, which probably means as soon as you start talking again, there's going to be another question.
And thank you for keeping with me. I really appreciate it. So we can see that there's actually, this is complete, and we have a bunch of tables. And let's do a really quick show of why aggregation is tough for this technique, right? So I want to look at both fact customers, right? I can do select star from, right? But guess what? There's my data. But what happened if I want to aggregate it? Oops, now I have to do this. And we can see this gets quite complicated when we have more than one, right? So now we can do union all, right? And now we can do this, select star from, and then just change the date or the quarter, right? So this is 2. So now we can see it's 123,000. It should be about 250,000 maybe. Let's see. It's gonna take a little while because it's going against 2 of them. See, 250,000 right there, 248. So that's the negative of that technique. Okay, so let's Wow, half an hour's already flew by, so I'm going to try to keep up on time. So the next one is partition view, right? So partition view, same thing. Going to drop database. We're going to make one database this time. We're going to create some fact and dimensions, right? Going to create these static tables pretty much, right? Which is the dimensions. Going to create a function. This function now is just going to return, given a string, return int. Anything else of interest? We're going to move the data over for both the pig packages and the date dimension. This is the actual workhorse right here. So cursor again, which is a while loop basically in programming. And what we're going to do is for each one, okay, we're going to make up a database name partition view. We're going to alter it and we're going to add a file group, okay? And that file group, we're going to name it accordingly to the dimension. And we have here's the dimension, and this is the var tagged, right? So it's the pieces. Then we're going to add a bunch of constraints, which we did before, which is primary and 2 foreign keys. And then we're going to insert data, right? And the interesting thing is the insert data. Guess what? We're going to insert into fact customers with no lock. So we don't have to insert it into this. We're inserting it into the view, right? And then we actually I haven't created a view yet. We're inserting it into the table customers. And this is customers with, see right here, the actual piece because we're doing tables, right? And then once we get them all together, we're going to create a view. So we have to do another cursor. And what we're going to do is we're going to select and union all of them. And then we're done. So let's run this. Oops. Come on. There we go. Okay. So now if we hit this, before sharding by or partitioning by database, now we're going to partition by table. So if we go to tables, we can see a table. So let's look at what's behind this database, properties. Okay, so we can see now we created a file group, okay, for the view, and we have files, right? And we can see now that we have a file group and a file associated to it, right? And now if we hit refresh, okay, we got another one. So now if we go here and go to properties again, we can see that basically before we had databases which had a MDF and LDF, and now we're doing the same thing for tables, but we only have a file group and file, okay? So we can see it's the second file group and this is the second set of files, okay? This is going to take a little time to run, so I'm going to go back to the slide deck really quickly, and then we'll come back and talk about the details. Okay, so again, ignore this. It doesn't, work anymore, or at least apply, is you don't need the enterprise version. It's also on standard, okay? Before, we were reducing the size of the database by n, which is the number of partitions, right? And putting it into a separate database. Now we're doing the same thing, but putting it into a separate table, which is on a separate file group, and it's on a separate file. Why do we want to do this? Pros is, guess what? We want to get rid of a quarter of data. We just do drop table. Again, it's a metadata thing. Cool thing, and I'm going to show you, is the query analyzer determines the table automatically, okay? So that's a really cool thing. We'll look at it and we'll see the plan, and it's awesome. Cons, right? We have to list out to do a union all every single column in each table in the view since we're using schema binding, okay? Also, we need to write code to add, load, and delete tables. Not a big deal. There's a limit to 4,096 columns per select statement, okay, or the number of tables in a query memory. Okay, so there is some limitations, okay? Next thing we're going to do is compression. So let's go back and see if this is finished. I can show you the example in which the query optimizer understands that we have now a partition view. So let's
John,
see.
I do have some questions in the meantime.
Yeah.
I did say with you that would be typical
Awesome.
that once I said no questions, there'd be some. So first question was, doesn't normal SQL Server have distributed keys?
I do not understand that question. Maybe you're talking about Synapse again?
It was yeah, it was going back in context to what you were showing literally about 30 seconds after you asked me if there were any questions earlier.
Yeah. So I don't know what you talk about distributed keys. What we're doing though is there's table partitioning. We'll get to that. It's a technique that Microsoft developed, which you do create a partitioned schema and a partition function, and we'll get into that. But that's not what I was talking here. This one is basically, we talked about initially making databases and segregating by database. Now we're segregating by tables, and then as a view that actually joins them all together.
Yeah, it could be. I've asked for more context. Maybe potentially it is not confusion as such. Maybe they're thinking about partitions.
Okay.
Anyway,
Yep.
and there is another question for you as well.
Sure. Go for it.
How does the optimizer suffice working with separate databases? Should the execution plan be created right after implementation, or just use option recompile?
Good question. I don't recompile them like gives you a plan each time. The hard part is the application front end. Remember that, right? The aggregation, right? So if you want to see everything, then you kind of have to do an aggregation, have like another database that aggregates this all together. And now you're doing cross database queries. So the database sharding is really good for an application that says, hey, I only need to work with a quarter of data most of the time, but maybe once in a great while I need to go back and look at a prior quarters or data. Perfect example. Partition views. I want to show you the optimize, and that's what we're getting on right now, is how it just automatically knows which table to go against. Any other questions?
No, that's all at this moment in time. I'll let you know if there's
Awesome.
any more, John.
Let me show you the optimize. This is the coolest part. This is like, why we did this, okay? And this is a technique that even Adam Mechanic used before they came out with enhancements to like allowing you to partition not only the table, but also the index. And I'm right now just worrying about tables, but you can also have partitioned indexes, right? So if we do select star from and then fact customers, ooh, it did this, okay? Let's stop this and let's do a display executed. Oh, wow, look at this. It's already smart enough to know that it's going to pull all the data from every single table, right? Wow, that's cool, right? Also, if we reference the column, right, that is the key, right? So it's this guy, right? And we type a where clause, then we can go to this one and do 2011, right, and say 04, and now we execute this again. And now I'm going to stop this if I can. Oh, I didn't do it, did I? It's an extra zero, maybe, probably. There we go. Stop this, and let's look at the estimated. That's one of these. And do the actual or this guy. This is what happens when I get old. Can't see anything. This is the actual. I'll just run it again. I don't know why that's made. Here we go. So we can see now it's smart enough to know that this one, it didn't need to go ahead and run them all, right? So it's actually a computing scalar, and it actually uses only the one index on the one table. If we go back and run this again, we can see it's smart enough to know that we could do something like maybe something interesting like customer underscore. And again, I'm good. This is just totally not scripted. So again, just bear with me, customer package key and then count. So for instance, I want to know what people are buying, right? And then what I'll do is I will change this to, at the beginning, we can also put in the customer underscore quarter underscore key. And now we can just change this to a group by, right? And let's see what this query is. And it should hit all shots, right? And now if we look at the live statistics, there's a syntax error. Yep. So now, see, it's doing parallelism. So you're getting some serious parallelism here, and it's doing everything on all each one. It's doing a hash match, a concatenation against the clustered index scan because, I didn't give any other indexes or where clauses. And then eventually it's going to come back. Okay, there you go. So per quarter, we can see that 1 and 2 are done. And this is the way I created the data, and 2 and 3 are done for the next one, 3 and 4, and so on. So it just increments them, right? But it's kind of cool. And then now if we go back and change this one more time, and then we'll get on to compression, because we're running out of time. This only goes to 1. And if we go to results, guess what? We got the operators, but we also have, hey, it found the answers, right? Okay. So why do we want to use compression? Okay, this still applies nowadays in the cloud, right? Because remember, a lot of the services that are software as a solution, okay, services, the problem we have is that the disk is slow. So faster we can get stuff into memory, which is always fast, the better, right? Two ways of doing compression: row level. Row level is just basically finding things that, say I made a char 25. Guess what? We're only using 4 always. Bad design, right? Someone modeled it wrong. If we change it to a varchar 25, suddenly now it's 1 byte and a number of bytes overhead. Guess what? We save a lot. Same thing with like big int versus a tiny, right? Page level does 2 others. It adds 2 additional compression techniques: prefix and dictionary. Okay. Prefixes basically find things in the data, say like a string, and put them into a dictionary, and then put a pointer to it. And then guess what dictionary is? If I see patterns like that in my dictionary already, then replace them with more pointers, okay? And again, look at books online. It probably has a better example of me trying to explain it on a rush. We're going to go into compression example, but I'm feeling like we're running out of time a little. So I'm going to talk about table partitioning and then do 2 examples at once, right? So to design table partitioning, we're going to create a file group and corresponding files that will hold the partitions, right? Partition scheme. Now this is the hard part, the partition functions, right? We have to either map left or map right. And what we have to do is the rows tables based on a specific column, right? So we're still going to use that hash key column. The scheme now is actually going to give it into a partitions, right? We're going to say, hey, create on this partition, and it's all internal, right? And then we're going to create or modify the table index to specify the partition scheme as part of the storage location. So, on primary, now we're going to do on schema given a value, okay? And so we're going to do partition example and data compression at the same time because they both use it. Let's talk about diagramming, right? Right now, we have something similar to partition views, but guess what? It's all handled under the hood by the engine. So we're going to say customers, and we're going to say, hey, guess what? We want this partition scheme in this partition function, but guess what? It's going to map it to those file groups, just like I did with the table partition views and mapping it to tables, which map to file groups and files, okay? Pros. You basically, again, we're defining storage schema over n file groups, so we're defining, right? Deleting data from the system is a lot more complicated, right? We have to do a switch, a merge, a drop table, a remove file group, a remove file, right? Cool thing is query analyzer determines the table automatically. When I get to results, it's the one that probably performs the best. Again, this doesn't really apply. Must write code to add, load, and delete partitions, which could be complicated. And all the techniques I showed today, this is definitely the most complicated. There's also limitations in the 32-bit, which hopefully no one's using anymore. It's 1K of partitions, 64-bit, 15K, okay? And a sliding window is, think about this. We have a bunch of buckets. So I got, coffee cup 1, coffee cup 2, and coffee cup 3. We want to add a new bucket, coffee cup 4, right? So we put that at the front. But we want to get rid of some old data because we only want to have, say 4 quarters on line. Say we had 5 of them. So the sliding window is dropping that old partition off and adding a new partition. Okay. And again, it's a bunch of coding to do that, okay? And then we're gonna do how the bake-off, how do the results, okay? So got about 15 minutes, so I think I'm doing okay on time. So I'm gonna close this. Gonna close this. And if we're curious, this one finished, right? So now we're gonna open up compression. Now, one of the guys that I actually have his book up here, Paul Nelson, and he's from the UK. One of my heroes wrote the SQL Server Bible 2015, okay? And this is from him. You can go through and you can use it, and there's a thing called estimate compression, and you can run it. And you can, the interesting thing, it's using a stored procedure, okay, that's no longer in Azure SQL. I don't know why they put it out there, but basically internally, if you look at it, it's actually taking a small segment of the table, putting it and trying the compression techniques, okay? And so with that said, okay, I just put that there to give them a plug. I am going to use my own, and we're going to do the old-fashioned way, right? We're just going to use Big John's, okay? And then what we're going to do is, this is Paul Nelson's, but we can do it the old-fashioned way and just say, hey, what's SP space? Oh, well, and again, what I'm going to do is I'm going to go down and make sure we have none on, right? So we're going to alter the table, rebuild it, data compressions, none, and we're going to look at the size, right? And so maybe I don't have a go statement here, so we'll do it one at a time. So this guy, so we can see right here that the rows, and again, I'm going to put this into like a little notepad on the side and see what's going on, right? So we can see that this, I wanted to copy with headers, delete, right click, copy with headers, and then paste this in. And just some notes to me and to you, because, you know, like I said, this is going to be no compression, right? Okay, so we see that this is a very small table. It's rows. We can see that was reserved. We have, come on, go over. Wow, there's a lot of things here. Anyways, just want to pretty it up a little. And tab it over. There we go. Close enough, right? So we can see that the data is 72, unused is 112, and we got 248, okay? So we have no compression. What we're gonna do is the simplest one, like I said, but might not give you the best compression. Now, there's times in which you put compression on it, it actually makes it worse, right? And again, I should have known one at a time. So execute. Actually, I have these right here, but I'm doing it again for the heck of it. And so we can see now that the data went to 48, right? See right here. And we can see in our old that it was 72 without, okay? And now we can change this, okay? And we can do the percentages minus 27. We can do a page compression, okay? And now we can change this again. And we can see that it went to 32, right? So we're saving data. Now, what's the cost of this, right? A few added CPU cycles, okay? So that's what's going to happen. If we want it back, we just go ahead and rebuild it back. And again, I don't know why I'm doing two at once. And this should be, it didn't work because I can tell the data is the same. So we're going to do this, then run this again. And now we're back to 72. So anyone have question on compression? No questions? And again, if you're curious, let me see if I can get this up really quickly. SQL Server compression. Oh, where is this 10 page? Why didn't it hit this? Take a look at, you know, data compression, and they have some really nice diagrams here. Hopefully, this is the column store one, so we don't want that one. That's the one I want to tell you. So row's easy, right? You can conceptual it real easy. Hey, I'm taking an int, right? It's 8 bytes. I want to make it a 1, so now it's just a bit, right? Page is a little more harder to explain, and this is why I brought this up really quickly. So page, we can see that we have AAABB, right? And so now what we're doing is, and we have AAA here, BCC, and what we're going to do is we will make this empty, right? And we're going to say this is the first 4 AAAB, and this is followed by a B. Okay, so this is the dictionary element followed by, it's a 4 followed by a B. This one's empty because it matches exactly the dictionary one. And this one says take the very first 3 and follow it by C. So we can see this is how it's doing the very first level of compression, okay? The second level of compression is, okay, now we see that we got a different value, but guess what? The pattern's the same. So now we can go and say, okay, these both point to 4B. So now it's a second level of dictionary compression, okay? And that's how it gets that awesome compression that we saw. So I'm gonna do the last example. We talked about compression, and we're gonna go into uh, partitioning. Okay, so far we've created a bunch of database. We have these and we have the partition view. We're gonna create the last one called table partition, okay? Going through this, nothing to write home about. We're creating some schemas, right? Gonna create tables. Gonna use compression this time. So we're gonna say on primary with data equals compression. Not that we had to. We're also going to use the same function. We're gonna create pig packages, right? We're gonna load the pig packages. We're going to create a dimension table. Okay, and then we're gonna create this function. And the interesting thing is when you create a function, it has to be at the top of it. So we have to do execute to have it work. This is kudos to Kaylin Delaney. I actually got this from her. And again, we were talking about Kevin, SQL internal. She has this there. And this is just basically giving us a mapping, okay, on petition information, okay? And then we're going to make, there's different ways to do petitioning, okay? So here's the problem with petitioning. Say I petitioned on just 2012-01, right? That's my first, quarter of 2011, right? And I'm going to change the year. The problem is if I put in 2010 data, 04, it's going to go in 11 because there's no place below that, right? It just says, well, it's to the left of it, right? Anything left of this falls into that petition. I always use a hospital petition. So that means that I'm going to have to, at the beginning, put something called 00 hospital. You know what that gives me is that if I get invalid data, it goes in that petition. I also put one at the end, right? So anything greater than the last 2012-04 goes in that petition. If you write a query when you're doing this technique, you can see if anything in those two petitions using Kaylin Delaney's query above, then guess what? We got bad data, okay? So that is something that we want to take care of. So I'm going to run all the way up to the one I showed you and run this. Okay, did it finish? Awesome. Now we're going to refresh this. Okay, and we can see now we have a table of petitioning, and we got tables. And in the tables we have dim date and dim package. We also have a view, right? And so if we select from this view, nothing yet, okay, because we haven't done any partitioning. Okay, so we're almost ready to create the petition table. Let's go down and see if we can get this a little bigger. Okay, so same thing, we have to do some type of looping because we have 8 of them, right? And this is a, curse is good for this. So we're going to create a partition function. And what we're going to do is we're going to say start at the hospital at the beginning. And then for each one, we're going to alter the table and create a file group, okay? And then we're going to alter the table and create a file, okay? And then what we're going to do is we're going to keep on doing this partition function. Then we're going to add the last, which is 99, which is the end. And then we're going to create it, okay? So execute this. Okay, so now it did it. What did it really do, right? What's behind the scenes? What's the proof in the pudding? If we hit properties, okay, and go to files, we can see now that we have these file groups that map to files, right? And we can see that we have, there's the files and here's your file groups, right? So we can go down and we get our 2 hospital tables, okay? And now if we go here and we execute, there's no data. So this is showing you the data. It's not going to happen yet, okay? So now we've created also, where does partitioning live, right? Partitioning is basically starch. So we did a partition function, and a quarter. So now this function, if we script the partition function as create2, okay, this one says that the values, anything less than 2010-04 goes into the hospital, less than or equal to. Otherwise, the first one, valid values for the first partition, FN group, 1 for 2011-001 is this value, right? That's your key. And also, if we go into the partition scheme, we can see it's mapping correctly to each of the ones that we created, okay? So that's what we just did. Now it's going to put some, we've created the functions, but we haven't created a table yet. So the magic is when we create this, we have to actually have part of the clustered key, okay, the customer quarter key, and also on the customer quarter key, we need to use this function. It's not on primary, it's on this function, and we're going to do data compression, okay? So I haven't loaded any data yet, but now we're going to create a table, okay? And if we go to tables and we hit refresh, the new table will show up, okay? So now we have it. And now we're going to just basically, it knows where to put the data. We just do a select into, we don't have to do it, okay? Now, if we're curious how this is working, we can hit here and see now we get all the partitions, okay? And maybe it won't wait. It's probably, because I did as a single transaction, it's all going to show up at the same time. So we just got to wait to this finish.
Just gone into the 5-minute region, John, by the way.
Trying. It's like it's too much to get into, okay? Now, I could go ahead and show you that inserting bad data will show up here. I'm going to leave that for a target there. No, what I'm going to do is I'm going to show you how to create the hash keys, right? So we're going to create a partitions, and what we're going to do is we're going to just add the data here. And now I'm going to keep track of this internally so I can do a sliding window, okay? So if we go here and we hit execute, okay, and we hit refresh, right? Now we have this dim partitions, and if we select from here, okay, we can see it's 1 through just the validate, okay? Now, how do we add a new one, right? We have to create some functions, right? So we're going to create a user-defined function USP, right? Add customer partition. And what's going to do, it's going to use that information, okay, to alter the database and add new file group, alter the database, add a new file, alter the database and set the next used, and then split the range, okay? So we're just adding at the end, okay? And again, I'm going to have to give you this as homework to do because I'm not going to have enough time to do this, right? And so what we can do now is this actually creates 1 at the end. So we're just going to run it. Execute. Okay, so there's all the statements it did. And guess what? When we run this, now we're going to have a new one, right? So now we see we have a new partition at the end. This is your sliding window. So we're going to add a new one to end. Now we need to drop the one at the bottom, right? To do that, okay, we have to go ahead and create a new table on that partition, swap the table out, and then drop it, okay? So this one right here, whoops, did I hit all the way down? Sorry about that, I did. It's almost there. I'm in cursor problems, I apologize. So this is the temporary table right here, right? And then we're also going to create a function to drop the old table. Okay, and again, it's getting information to do the switches and stuff. And I'm just going to run it and we'll go over the statements it does and then we'll wrap it up. So we're going to go here and we just execute this, okay? So now we created definitions, but I haven't really done it. And if you look, this USP delete partition, right, it's going to call the other one that it should execute add a customer table, right? And then it does switch to the customer table, right? So let's run this. And again, you can go look at it. And what I'm doing is I'm displaying all the techniques. So we first had to execute, create a new table. Then we had to go ahead and switch. Then we had to alter partitions and merge ranges. So we wanted to merge the first and second ranges. we had to drop the petition, we had to remove the file, move the file group. Then we had to update the petition schema and the petition function. The schema is next used to put it back to the hospital once, right? And again, I'm going to let you go ahead and look into how data would go in the wrong section. But now, guess what? We can see that 2011-01 is now a hospital petition because it's no longer valid. And 2011-02 is now our first petition, okay? So end of demos, let's get to talking about discovery of which one's better, okay? This is very subjective, so I'm going to let you do your own testing, but show you what I did, okay? So I just did a full table scan, right? And I looked at minimum of CPU time, minimum of lapse time, okay? And if we go ahead and just plotted it, we can see that doing nothing, okay, with a full table scan is very expensive. It takes 2 seconds, right? If we look at the partition view, it's just almost as good as table partition, but table partition works out the best. Partition database sharding is not that bad too, okay? And last but not least, add a non-clustered index and then basically scan it again. And guess what? We can see that, wow, Big John barbecue, way off, 4 or 5 seconds, right? But guess what? We can see now that these are almost the same, right? The sharding versus the view and the table partitioning, they're all, a third of a second, okay? So that's about it. I don't know why I went to biography, but there's a bunch of Wikipedia shards. There's a lot more now. Go look at SQL tips, but shards, horizontal partition, partition views, partition tables, files, and implementing, okay?